Manufacturing Matters is an MFG Radio Network production brought to you by GIE Media's Manufacturing Group as industry experts take deep dives into the latest manufacturing matters, whether it's new innovations, products, technologies, and emerging markets that help you understand better why manufacturing matters to you and also to the top companies in the medical, aerospace, defense, and electric vehicle manufacturing industries. Hello and welcome to our latest roundtable discussion from GIE Media's Manufacturing Group, the right cutting tool for the job. I'm Jake Kaufman, the managing editor for the Manufacturing Group's magazines. We have 5 of the best industry minds waiting to answer questions, but first we'd like to thank today's sponsors, ISCAR, Greenleaf Corporation, Allied Machine and Engineering, Third Wave Systems, and Kyocera SGS Precision Tools. We're also glad to be joined by Andrew Benson, the President and Chief Marketing Officer of ISCAR USA, Dave Beam, Greenleaf Corporation Sales and Service Engineer for Minnesota, Iowa, and North and South Dakota, John Wenninger, the Product Manager at Allied Machine and Engineering, Nishant Sani, the Director of Business Development at Third Wave Systems, and rounding out the cast, we have Bill Sebring, the Vice President of the R&D Technical Center with Kyocera SGS Precision Tools. So, gentlemen, thank you so much for joining me today.
Jake.
Thank you for having me.
Thank you.
Thank you.
So we will begin the discussion with Dave Beam over at Greenleaf. As I ask you, Dave, what are the first questions you ask a customer when they're looking to purchase the correct cutting tool?
Thanks, Jake. I would start off, I don't really start off with anything real technical right out of the gate, but the first thing is to ask the customer, are they hitting their profitability goals? Are they usually accurate when they quote work or quote jobs and parts? If they're not, then I try to start asking about what they're missing, right? So is it particular materials that are causing your issues? Is it particular processes or a particular work center, for example, like a mill versus a lathe or type of equipment? To start focusing in on, something to be able to correct and address. I think if you ask most owners if they're profitable or not, they would generally ask they would like to be more profitable, but try to get down to where they need the most help, so we can provide them with the fastest way to get them up and running and make them happy. So.
Awesome. Thank you, Dave. So we'll go to Nishant Sani over at Third Wave Systems with the same question. What are those questions that you would ask a first-time customer when they're looking to purchase the correct cutting tool?
Yeah, for us, it's a little bit different what role we play in the process. Our first natural question is what kind of material you're machining. That becomes the key driver for everything that follows. And then it also is an aspect of whether you're in early stage, say new process introduction or new product introduction stage, or you're in continuous improvement kind of an issue, because that gives you the flexibility. The early on you are in the process, the more changes you can make or more flexibility you have with your cutting tools, your tool paths, your fixturing, and that all has an impact in the process. So I think it really, like Dave said, depends on the situation.
Awesome. Thank you, Nishant. So we'll go over to John at Allied Machine with the same question. What are those questions that you would ask a first-time customer when they're looking to purchase the correct cutting tool?
Sure. Yeah. So I think we're really all dancing around it too. There's the basic questions I think that we need to ask, the material, the hardness, diameters, depths, tolerances, all these kind of questions really to understand what the application is. And then I think it goes a little bit beyond that too, in terms of asking what problem are we trying to solve? I think that's a big question that a lot of sales professionals don't really get into. And we need to start asking those questions because ultimately, the customer has a problem. So we need to see what that problem that they have is to try to prepare some sort of solution to really combat that. That's the thing that they're after is, the root of their problem. So rather than trying to sell them something, I think it's working with them to better understand, their application and what's the right tool or the right path forward, I think, for their shop.
Awesome. Thank you, John. So then Bill over at Kyocera SGS, if you want to wrap up this round of questions for us, what are those questions that you ask a first-time customer when they're looking for the correct cutting tool?
Yeah, so the panelists pretty much, they all mention workpiece material and hardness. For us, it's the same basic question. We also try to understand the overall process in general as well. What kind of machine tool are we looking at? Is it vertical? Is it horizontal? Is it multitasking lathe? What spindle size? Is it a Cat 40, Cat 50, HSK 100? The age of the machine, is it fairly new and rigid, or is it something that's a little bit older? How much RPM do we have available to the application, which will help us understand cutting conditions? And then lastly, what tool paths are they looking to use? Are they looking to use traditional tool paths or something like trochoidal tool paths? So we just try to understand the overall process in general. And then lastly, what tool holder they take, or do they prefer? Is it a milling chuck, a welding holder, shrink fit? That also comes into play in terms of rigidity and how the tool will perform in the situation.
Awesome. Thank you, Bill. So we'll bring Andrew Benson into the discussion for our next round of questions as we ask him over at ISCAR, when you're speaking with an existing customer, how often do you offer to reevaluate their systems and make sure that their current setups are working at their best possible levels with so much new technology coming into the market?
Okay. Yeah, thanks, Jake. So, there's really no one set time period, but I would say from a holistic perspective, our advice is to continually review. And we also suggest during that review is to include the cutting tool supplier in that review, because then you're going to get access to really what the latest ideas are. And what's important here is that interaction, because we listen to our customers, and ultimately that's what drives that R&D process at ISCAR. Those are the challenges that come up, and then from those challenges come those next innovations that we actually bring to market. It could be a couple years later, but we learn a lot when we're interacting with the customer. So listening to the customer is important. But basically, when we review, what are we doing? We're looking at time. That's the number one thing. How do we take time out of the process? And then number two is those process inconsistencies like breakage, tool wear, things that they want to improve. One of the challenges, of course, with trying to do this is the shortage of, process engineers in the shop to be able to make these changes. And I think that's one of the biggest challenges facing the industry is to get staff, qualified engineers to be able to do this. But just some recent examples of things that machine shops can employ now would be like precisely directed high pressure coolant. With additive manufacturing, we're actually employing that now in the cutting tool industry, to make cartridges and tools with precisely directed coolant to reduce cutting temperature, which can extend tool life by maybe up to 50%, or it could increase your feed rates, et cetera. So I would say the bottom line is yes, do it often as you can. And when you do it, what you're doing is you're creating opportunity for your company in terms of more capacity to be more flexible and to do more. So, but definitely include your cutting tool manufacturer. They can be a great ally to you to help make improvements.
Awesome. Thank you, Andrew. So Bill Sebring at Kyocera SGS, once again, we'll go to you with the same question. How often do you reevaluate an existing customer setup with so many new cutting tool technologies coming onto the market?
Well, sometimes with these advanced geometries that we have today and the increased speeds and feeds, sometimes the workpiece fixturing could become a limiting factor. So as our application engineers are in the field working with our customers, they see a lot of different setups, a lot of different technologies and different ways to hold products. If we are experiencing some tool life issues or some chatter or vibration, the workpiece fixturing could be a source of that problem. Again, we're talking about an entire process here. So it's the machine, the work holding, the tool holder, all these things together as a system. So the workpiece holding certainly can come into play at some point in time.
Awesome. Thank you, Bill. So John Wenninger over at Allied Machines, same question to you. When do you reevaluate an existing customer setup with so much new cutting tool technology coming to the market?
Yeah, thanks, Jake. I mean, I really do think it should be continual. Really, like Andrew said, I think it's something you should always be looking at to improve your process. Obviously, we don't want to get into the constantly improving that's delaying our manufacturing time, putting hiccups in us trying to make parts and to make a profit. But it's something that you need to have access to the latest stuff in the industry, the latest technologies, be able to push your tools and your machines as hard as they need to be pushed in order to maximize that profit. And, I'd say too, utilizing the distributor reps and utilizing the vendor reps too. That's, these are folks that are out there constantly all day long, investigating multiple different lines, finding where they've lost, finding where they've won to cultivate, the right approach, I think, to that specific application. So, and maybe it's not always right for every customer. We're talking about the newest approaches for, a specific part that we're making thousands of is one thing, but then you talk about maybe a job shop and looking at how do we set ourselves up for success long term in our shop, employing the right systems, the right tools that we can use across multiple features, multiple parts. So again, I think it's just utilizing those industry professionals and those industry leaders, the field reps, the vendors, the distribution reps that are out there that have more access to things that you might not have considered in the past.
Awesome. Thank you, John. So Nishant over at Third Wave Systems will ask you the same question when it comes to reevaluating a current process. How do you do it with so many new cutting tools coming onto the market?
Yeah, I think we sort of sit in a unique position here. I think key thing is to help them do this virtually. So I think John mentioned about lack of availability of process engineers, but it's also the production time that you have available is also challenging to get. So the more of this testing that you can do virtually, the less disruption you should hopefully have on the production shop floor. And that's the idea, that do as much as you can before you get onto the floor. And it's a system, like Bill said, right? It's cutting tools, the tool path strategies, the workpiece fixture holding, and depending on what flexibility you have, those are the variables that you play with when you're looking at reevaluating the system.
Awesome. Thank you, Nishant. So we will wrap things up with Dave over at Greenleaf. With the reevaluation process, how often do you do it with new cutting tools coming onto the market so often?
I would say if I had advised an answer, it would be to do it frequently, particularly if it's a process or part that's mission critical to my customers, right? So at Greenleaf, we kind of end up having pretty intimate relationships, almost like we're a fifth wheel in our engineering team a little bit. So it's our goal to know what the customer is going to, to see their problems before they run into them. Then we can advise on ideas and improvements and trends before the customer actually thinks they need it. So.
Awesome. Thank you, Dave. So we'll go to the next round of questions with Bill Sebring over at Kyocera SGS. So with so many different tool designs in the cutting tool industry, how can you make sure that the design fits the specific application and the materials being used?
Well, materials is the starting point. As we develop cutting tools, we're selecting from various grades of carbide that we have available, and selecting that grade for the material and the application is the first step. We then take a look at PVD coatings that we have. We have many proprietary coatings that we can utilize to help protect the cutting edge against thermal wear and abrasion. And then lastly, we take a look at the geometry. We can grind a lot of different geometries. Whether it's a 4-flute or a 5-flute tool that can be used for slotting or profiling, or it's a multi-flute tool from 6, 7, 9, 11 flutes for finishing and those types of things. And when we decide how many number of flutes we would like to have, we then take a look at the macro geometry, such as rake, helix angle, or we can apply any variable geometry and such to help minimize vibration. And then lastly, looking at the microgeometry. Are we applying any cutting edge radius, any post treatments to coatings and the like to help really dial in that tool and be the highest performing tool that we can develop for a particular material.
Awesome. Thank you, Bill. So we'll go to Nishant Sani at Third Wave Systems. So same question to you. With so many different tool designs out there, how do you make sure that it's the correct tool for the application and the material being used?
Correct. So I think one thing that we notice is that it, say we're working with a process engineer, it all depends on what their level of expertise is with, say the cutting tools, what has worked well for them in the past, right? That's their reference point, and how can we enable them to do a lot of what Bill was talking about, the microgeometries, the step over, step down, all of that. It is based on experience, but can we add value that they cannot see otherwise, right? So, hey, I don't have the time to do this on the floor. Can I at least narrow down my choices working through it? So, and sometimes I feel like the cutting tool gets the blame sometimes more than it should, because it works as a system, right? The problem could be the toolpath, problem could be the user didn't know what the right application was. So it could be many different places. And I think that's what we have to be cognizant of. And a lot of times the cutting tool company applications engineers are tasked with figuring that out. Like everything on the floor is the problem. So now you help me what to do with it. So
Awesome. Thank you, Nishant. So we'll go to Dave Beam at Greenleaf with the same question. With so many different designs out there, how do you make sure that the design fits the application and the materials being used?
I would say the angle I think I take the most, and I would think I'm speaking for a lot of our sales engineers, is that we kind of prioritize the cutting action itself, where the tools meeting the material. Then we kind of design a system to support it. So we don't want to put ourselves in a position to compromise our solution or our name and reputation along with it. So internally, we test what we're developing prior to ever reaching a customer, so we're knowledgeable in supporting it once it is in the field. And then from there, we drive our testing from our results. We provide just spindle data to anything we are testing and validate that investment our customers making in our tooling. This puts us in position with customers who are entrusting us to make the best position and be successful as possible. So.
Awesome. Thank you, Dave. So we'll go over to Andrew Benson at ISCAR to wrap up this round. As we ask you, Andrew, with so many different tool designs out there, how do you make sure that that design is the right fit for the materials and the application?
Yeah, so being probably the old guy here, I'm going to take a historical approach to this. Okay, Jake. So I think if we turn the clock back, we look at how people got their information, and that was through product literature, right? You would get a catalog from the manufacturer and you'd flip through it and you'd select what you needed. The second thing was use a telephone. You call your factory rep and you say, hey, I have this problem or I have this application. Then with that, the generation of websites, when the internet became more popular and usable, the manufacturers had put their product catalogs on websites, and it made it easier to search, and that continually improved. Well, if we fast forward to today, the newest thing is now to have knowledge-based systems available, to the customer. And these are constraint-based linear program type models that use sophisticated search engines. And, the advantage of these is instead of just looking for a tool and selecting it, what you're doing is you're looking at the constraints of the problem. So the constraint can be, it's the type of machine, the rigidity of the machine, the fixturing, the torque curve on the machine, the material that you're cutting, and a lot of these things were already mentioned. But basically, looking at it from a software standpoint, you're able to look at all these constraints, and then you can look at the knowledge base of all test reports and applications, and then return the best tool for that particular application ranked in order by material removal rate. And then basically it's just hey, this is the particular one I would like to use. But, the advantages of these newer systems is you can get immediate information. In addition to that, you can get the digital model of the tool, so you can immediately begin to, do your programming. You can get the assembly and bill of materials, so you can expedite the ordering process. So I think, from a selection standpoint, in addition to everything all these gentlemen had said, I think that the latest in knowledge-based systems to help support decision is a real game changer now going forward for the machine shop.
Awesome. Thank you, Andrew. So we head to it, Nishant, with our next round of questions over at Third Wave Systems. So how versatile are today's cutting tools? Can tools be used to make multiple different products, or are they more valuable if it is a specific tool for a specific product?
Yeah, no, I think I have to honestly say that I think the innovation is tremendous on the cutting tool side, right? And our role here is to support those innovations. And I think increasingly what we are finding is that the more tailored the solution is to a particular application, the better the chances of success. Because you cannot take a tool that worked for, say, Inconel 7118 and put it on another nickel alloy, because the behaviors are different and there are other limiting factors as well. So I think my view is that it should be specific to the production process or the parts that you're producing, even down to the alloys that you're looking at. But I think I'm pretty sure that others will have more to say about the versatility of the cutting tools today.
Awesome. Thank you, Nishant. So we'll go over to John Wenninger over at Allied Machines. So yes, same question. How versatile is today's cutting tool? Is it something that can be used to make multiple different products, or is it more valuable if you have a specific tool for a specific product?
Yeah, I think what Nishant said is correct as well. There's a need for that tailored to the specific application, but I think within that you do have some versatility, right? If we look at drill bodies, for instance, certain drill bodies can handle a range of different diameters that you can put in them. Certain drill bodies can accept multiple grades of ISO inserts. Same thing when you think about boring tools, selecting, a versatile boring system that can, do OD boring, ID boring, fine adjust, large diameter ranges, solid carbide bars out to slides. So I think having that versatility makes you a little bit more dangerous when it comes to, the tools in your tool belt. And I think that's really something we're trying to do, is provide our customers more with less. I think that's kind of the name of the game in some degree. But then, thinking about it a little bit differently, I think it also is important to target specific applications, specific industries. For example, geometries targeted to aerospace applications. When we're talking about mold and die, common parts that we see, common features that we see in mold and die, getting specific targeted solutions to service those customers. Same thing when it comes to automotive, yoke manufacturing, things like this that we see on a lot of different levels at a lot of different accounts across the world. Having those tools that are more readily available to service them, it makes us a little bit more, like I said, dangerous when it comes to providing that right solution for that specific customer. A little bit more targeted, I guess I should say. So I think it's important to have versatility, but then when it comes to those specific applications where you can get a little bit more targeted focus to service a more broad range of customers, that's an important path to take.
Awesome. Thank you, John. So we'll go to Bill Sebring at Kyocera SGS with the same question. Where do you see the versatility of machine tools? Is it something where they can be used for multiple different products, or are they more valuable if it is a specific tool being used to make a specific product?
Yeah, as Nishant and John mentioned, the application-specific products for sure offer the highest level of productivity, performance, tool life, and reliability. However, you can have, for example, a 5-flute end mill or a 4-flute product that can, be a all-rounder type product and can be used in many different applications throughout a shop. It could be used in various material groups. It may not offer the highest level of performance, but it can be used in various applications, CAM programming techniques, and depending on the product itself that you're machining, how big it is a smaller part or a medium-sized part. You could, for example, have a 1/2-inch 5-flute end mill that's very applicable across a range of products in different areas of a facility. That also is valuable for a customer in terms of having a go-to product in the shop that all the machinists are familiar with, that runs in various areas throughout the facility. So if they move around the shop or work on different parts, they're very familiar with that tool and how it's going to cut and react to the workpiece.
Awesome.
Yeah.
Thank you, Bill.
If I may add, Jake, I think Bill brought up a good point that it's from a customer standpoint, also the end user standpoint, the commonality, right? How many SKUs do you have in the floor? I think that commonality is also a driving factor, which is sort of in conflict with the hyper-focused application-specific tools. So it is something that our customers are looking to do, right? And we have to support them in that effort.
Awesome. Thank you, Nishant, and thank you, Bill. We'll go over to Dave to wrap up this round of questions. How specific can a cutting tool get to, or sorry, how versatile is a cutting tool to where is it something that can be used across multiple different products, or is it more valuable to have a specific cutting tool making a specific product?
I'm going to reach out here a little bit different than everybody else's answer, just out of the world I get to live in. With Greenleaf, I guess a lot of our products kind of fall into two buckets. We sell a lot of carbide solutions, and we sell a lot of ceramic solutions. So carbide requires a lot more technical information. The details have to be nailed down in order to provide the most optimized solutions with grades and coatings and edge preps and things like that. It all tends to kind of be two different ways to apply the tools. The ceramic solutions, to be quite honest, can be quite versatile. We have a lot of product that we sell where we sell the same insert and turning and milling and a lot of other solutions, because the cutting, the action happening at the material is actually quite a bit different. So with that being said, a ceramic solution, for example, is more about the part hardness than anything else, and whether it's steel or stainless or Inconel or something, it kind of changes it completely. So
Awesome.
that's my spin on it. So
Perfect. Thank you, Dave. So we'll go over to John for our next round of questions at Allied Machine. As I ask, just how important is material removal and material removal rates using today's cutting tools?
Right. Yeah. I think a lot of this, my take on this goes back to that first question. What problem are we trying to solve? Asking the customer what they're after. Right. So when it comes to MMR, I think that's metal material removal rate. I think that's a really important thing that needs to be considered, especially in high production shops. Right. If you're making a singular component, you're making thousands and thousands of these, even shaving off 1, 2, 3 seconds, that time, that machine time really starts to add up. So, that's one approach for large scale production. But then when you look at smaller scale production, servicing all of the different markets, that might not be the most important thing. That's why you need to ask those right questions in the upfront. What problem are we trying to solve? How many parts are we making? That's another really important question, I think, to ask. Do we need to be setting you up with that? We just talked about the specific applications or the versatile applications. Can we set you up with more of a versatile solution that's going to be able to handle, some of these other jobs that you get down the road? That's not something just targeted to this application. So it's kind of two schools of thought there. But a lot of that boils down to, and this is what we talk a lot about when we have folks in for our training here at Allied in Dover, the cost per hole. We do a really big focus on cost per hole, and it's, what are you after? A lot of it's, machine time, cost per hour of that machine, your cost, and that's really the main driving factor. But then you got parts, you got tooling costs, you have speeds and feeds, penetration rates. So taking all those things together and looking at it more of a cost per hole standpoint is really what we try to focus on, whether it's drilling, boring, reaming, thread milling, all of the different operations really, I think, can be boiled down to that cost per hole. So sometimes that removal rate's important for some accounts, for some applications, and I think others it shouldn't be the main focus.
Okay. Thank you, John. So we'll go to Andrew Benson at ISCAR with the same question. As far as material removal and material removal rates, how important is it with today's cutting tools?
Yeah. So I think John made excellent points. To add to that, the metal removal rate, that's what we're charged to do. And if you think about it over time, everybody's pushing for higher and higher metal removal rates, both from the machine tool builder side and also from the cutting tool side. And why is it important? Because it drives the profitability of the shop. It's basically you're saving time. Anytime you can save time, it's time that can be deployed to something else and to make something else and to make more revenue for that shop. And, just freeing up that capacity and making that shop more flexible. You think about all the opportunities that come up. Now the shop can expedite faster. They have the ability to be more competitive and more responsive. Maybe they are on the edge of where they need to make a CapEx decision, right? And it's a little bit uncertain times right now, but they need to produce that job as fast as they can. By looking at the process and gaining that capacity for your shop, you can maybe put off that CapEx decision for a future date and, drive revenue for your shop. So, I think good tool selection is the key, and the metal removal rate is always going to be important, because it's a time-related function, and I think profit is the objective of any business. So I think that'll always be relevant. So thank you.
Awesome. Thank you, Andrew. So we'll go to Dave Beam at Greenleaf with the same question. Just how important is metal removal rate and metal removal in general when it comes to using today's cutting tools?
Yeah, I think like as John and Andrew had said, MMR is very important, and it's a target that a lot of people are looking at. But I think one thing we probably need to make sure of, and I try to ask all the time, is, how stable is their process, right? I think that's a big miss. It's not hit, not paid attention enough to, right? So is there tool life? Is there part, is that stuff stable? Is it predictable? In order for them to hit it, they need an MRR. They're hitting every part, every day, every hour, not just hitting it once and then struggling with compromises down the road. So.
Awesome. Thank you there, Dave. And then we'll go to Nishant with the same question. Where do you see metal removal rate and metal removal in general when it comes to using today's cutting tools?
I do agree with Dave on this, absolutely, that sometimes biggest or the fastest material removal rate is not necessarily the best thing in these scenarios, and stability of the process and making sure that there are no unscheduled downtimes are really where the throughput can accelerate, right? I mean, it's like me driving home. If there is no traffic on the road, I can go all, but if I'm sitting in the traffic, then it's a problem, kind of a thing, because if I have too many unscheduled downtimes, that's the one that is the killer of the productivity. So I think that's the thing that we have to focus on. A number of times, I think we see our users making trade-offs on material removal rate when it comes to aligning tool changes, right? So if I have to change one tool every 4th part versus one tool every 5 parts, what's my common denominator here? And can I align them? Because that disruption of changing tools is also an important element to consider. So fast material removal rates, yes, but in conjunction with what other aspects need to be considered for the throughput.
Awesome. Thank you, Nishant. So we will go to Bill over at Kyocera SGS to wrap this up. What is the importance of metal removal rates and metal removal in general with today's cutting tools?
Yeah, I agree with everyone that has mentioned that metal removal rate is a measure of productivity. It's something you can calculate. However, as Dave mentioned, and also Nishant, for me, stability in a process, reliability in a process are also extremely important. We can take an end mill, for example, and walk the razor's edge and push it really, really hard and really increase the metal removal rate. As Nishant mentioned, if we're changing tools more frequently than we should be, or it's affecting other operations afterwards, such as a finishing operation, leaving inconsistent material, then part quality can suffer. So at the end of the day, if we're not making quality parts that meet specification, then high metal removal rates did really nothing for us. It's about making a good part the first time and not having to rework, for example.
Awesome. Thank you, Bill. So for the next round of questions, we will start with Dave Beam over at Greenleaf as I ask, what are the common causes of wear on today's cutting tools and what's being done to avoid those and extend tool life?
I would say the 2 things I see the most of is inconsistencies in the materials itself. And the second thing, which could be the material itself, or it could be the heat treatment of that material. And then the actual physical properties of the parts themselves. With materials shortages, it is putting these people and these customers in a position where they're opening themselves beyond using their favorite forging You know, let's say they're doing titanium forgings or whatever, they have to get any material they can get their hands on. So they have to move away from their favorite source, the most predictable source. It puts them in a position where it's a moving target. The combined with inconsistencies in raw material, generates all sorts of problems for those who are having to machine them. Hard spots, inclusions and stuff, things like that. It's just stuff that is out of their control, which tends to be what I see that people are struggling with. So,
Awesome. Thank you, Dave. So we'll go to Nishant over at Third Wave Systems. As far as the common wear of today's cutting tools, what's being done to avoid it, reduce it, and also extend the life of cutting tools?
Yeah, no, I think the answers to this could be as varied as the processes that you have. There are different reasons for it. I think we boil it down to more essentially heat flow in the at the cutting edge is what it comes down to, understanding where that heat is going, whether it's going into the chip, the tool, or the workpiece. And it's important everywhere, right? We want all of it to go into the chip, but if it goes into the tool, it will cause problems there. It changes the stress that the cutting edge is seeing, and to be able to understand that information, I think is the way to make the decisions on what is the mode of failure. Is it the heat deformation that is causing it? Is it the constant, or no, I shouldn't say constant, but interrupted cutting for a milling tool, which is causing the chipping? So understanding those aspects, I think, is important. And it goes a little bit beyond the hardness itself, right? It's about how do you manage the heat that is going into the workpiece. So tool is good. We need to protect the tool, but we also need to protect the workpiece from whether it's work hardening or whether it's residual stress, whatever that may be. So I think it's a combination effect, and I think the answers are very specific to the scenarios that you're looking at.
Awesome. Thank you, Nishant. So we'll go to John at Allied Machine with the same question. Just what are the common causes of wear on cutting tools today, and what is being done to avoid it and extend tool life?
Sure. Yeah. In conjunction, I think with what Dave mentioned too, you know, material inconsistencies are a huge part of things that we see that affect tool life in an application. Likewise, you know, speeds and feeds. I say misapplying tools is a really huge factor that we see. Coolant conditions as well. You know, supplying coolant right to that cutting edge, reducing built up edge is a big factor. You know, taking care of coolant. I think what it all boils down to is what Nishant touched on earlier. You know, I think the cutting tool often gets blamed for application issues that can result, whether it's poor fixturing, you know, poor coolant, bad work holding. All these factors get blamed on the cutting tool. With that being said, you know, I understand that sometimes, you know, the vendor and the solution that you can provide that has the strongest chance for success, that inflicts the least amount of pain on a shop, sometimes is the option that makes the most sense to go with. You know, maybe, you know, if you just change X, Y, Z, okay, yeah, but here, you know, we're applying this tool and it's working and it's successful because it can handle your current setup. So if you did X, Y, and Z and improved your process, you're going to see improvements in your cutting tool. You're going to see less wear. You're going to see these things. But, you know, from Allied's perspective, I mean, it's really taking a look at, you know, carbide grades. It's taking looks at, you know, we've a big push to edge preps. You know, what we're doing to prep the cutting edge has been a really big focus of ours as of late, as well as, you know, unique coating combinations and tailoring that insert. You know, that work hole, whatever it may be, specifically to a customer's application. These are all important things.
Awesome. Thank you, John. So we'll go to Bill Sebring at Kyocera SGS with the same question. What are the common causes of wear on today's cutting tools, and how can you avoid those or reduce them and extend the tool life?
Yeah, I mean, abrasion, of course, and thermal conditions can break down the cutting edge. PVD and CVD coatings have long been used to help provide a thermal barrier and an abrasion barrier to help extend tool life. And those PVD and CVD coatings continue to evolve. Over the last 10 years, I've seen numerous variations of different coatings by adding other elements into the matrix of the coating, as well as different layering and or nanocomposite type coatings that we produce here at Kyocera SGS really help to extend the tool life and protect that cutting edge. But back to what Dave said, you know, a lot of these, the material removal, how the part is presented, is it presented in a similar manner every time? Is the metal removal rate, or at least that first pass around the outside of the part, is it in the same condition every time and not varying? Because that can really have an impact on, you know, what that cutting edge sees for the first time around until it gets underneath, for example, the skin or the a thermal heat treated layer on the outside of the part.
Awesome. Thank you, Bill. We couldn't wrap up this round of questions without talking to Andrew Benson at ISCAR. So we will ask you the same question as far as the common wear on cutting tools, what's being done to reduce it and also extend tool life.
Yeah, so I think the group, you know, covered those causes of cutting tool wear. I think to maybe look at this maybe from a little bit different perspective, if we look at industry, you know, industries, the products that they're making are changing. And if we, you know, look at an example of the automotive industry, right, there's a push towards lightweighting. And even if you look at the internal combustion engine, there's a push towards smaller engines that are turbocharged. And what's that mean? Well, those engines operate at maybe like 25-to-1 compression ratio. So it's very high heat. There's a lot of stress put on those particular engines. So that results in changing the materials that those products are made from. So you were in the automotive industry, you were typically cutting in the past steels and cast irons. And today, you're actually starting to cut, you know, more heat resistant alloys or high strength alloys. You're seeing more titanium, you know, Inconel type based materials, you know, for turbochargers, et cetera. And you can't use the same cutting tool technology to cut those materials. So, you know, we see that that's where our clients need help, is to understand, you know, how can I evolve with this change and cut these new generations of materials? What do I need to change in terms of the cutting tools? So, you know, and obviously those solutions are, you know, tougher substrates, more advanced coatings that are harder, you know, potentially produce a, you know, better thermal barrier, et cetera. So, you know, we have lots of options to do that, but you know, ultimately it's the wear on the cutting tool is ultimately a function of the change in industry and cutting more advanced materials. Even abrasiveness was mentioned. You know, you're seeing carbon fiber based materials, even the additive manufacturing, you know, those are finishing cuts, but those are typically harder parts, you know, unless they're heat treated somehow. So anyway, yeah, I think it's industries driving it.
Awesome. Thank
Part
you,
of it.
Andrew.
Mm-hmm.
So we will go to Bill Sebring over at Kyocera SGS for our next round. So as a cutting tool manufacturer, why is it important to build and maintain relationships with machine tool builders?
Well, customers are going to machine tool builders to buy machines, right? So they're a connection between us and the customer. You know, a customer will approach a machine tool builder, particularly if it's a high volume production part, to employ a machine or machines to make a part. And so we can be there to help support that process from product development, product parameters, selecting the appropriate tool, having some input, again, as we spoke on work holding previously. How would we hold the workpiece? What kind of tool holders would we typically recommend for the tools that are selected? And then lastly, you know, what kind of CAM software does a customer use, and what kind of programming techniques are they familiar with? So we can bring this knowledge that we see from many different places and in our knowledge base and help the machine tool builder deliver that product.
Awesome. Thank you, Bill. So we'll go to John over at Allied Machine with the same question. What is the relationship like with a machine tool builder? How do you build it? How do you maintain it?
Very important. You know, we have a whole team that's dedicated to our OEM machine tool builders. Couple different reasons, right? You know, like Bill said, you know, our customers are going to machine tool builders, you know, for a couple different things, but you know, turnkeys being one of them. So when these application engineers at machine builders are looking at a part, trying to select the best tools for it, you know, not everyone is going to come from a specific vendor. So, you know, each vendor has the things that they excel at and the things that they do really well. So you need to be a part of that in order to provide your customer with a best overall solution. And then I think it goes one step further too, right? You need to have, you need to be in touch with them to determine how the gearing, the drive, the horsepower, the thrust, as a lot of these newer machines come up, it's not like this old engine lathe where you can just kick it in gear and let the big dog eat, as we say. You have to kind of play to the machine curve. You have to more speed, higher speeds, lighter depth of cuts. That's something that we're seeing. So, we don't want to be designing tools and putting new tools into the market that can't run on this new style of machine. So it's taking these things into account altogether and cultivating, the new age of tooling to be sure that you can run and perform adequately on these newer style of machines, because ultimately, that's where our customers are going to have to run at. So that's where our new tooling is going to have to run at as well.
Awesome. Thank you, John. So we'll go to Andrew Benson over at ISCAR with the same question. How is it building the relationship with machine tool builders? Why is it important? How do you maintain it? Just essentially, what is it like working with the machine tool builders?
Yeah, so, I agree with everybody so far that it's a very important collaboration. And the reason is the machine tool and the cutting tool, both they advance together. And for example, it could be that the machine tool builder is able to improve the rigidity of a certain axis, and that allows the cutting tool manufacturer now to develop a more robust tool that can take a heavier cut. So we go back and forth with each other, making these continual improvements, and each other benefit, and ultimately the customer benefits from that collaboration. But even just looking at trends in machine tools, over the past, let's say 10 years, you see these let's say lower horsepower milling machines, and to be able to maybe get more material removal, you move to technology like feed mill, which has become very popular in the last 10, 15 years. It's been around for 20 something years, but more recently you're seeing lots of innovations in the area of taking smaller depths of cut but moving very quickly. But you can take advantage of those types of technologies. But again, working with a machine tool builder, just like any customer, it's a function of availability of the engineers and the resources. We all suffer from the same thing, is that availability of technical skill to be able to make change and support change. But ultimately, we think that that relationship is important. It'll continue to evolve, and I think those next generation products that come out are a function of what we do together today.
Awesome. Thank you, Andrew. We go to Dave Beam with Greenleaf to wrap up this round. So maintaining, building, and just establishing those relationships with machine tool builders. Why is it important, and how do you do it?
I think the best solutions are marriage of the right tool and the right machine. We build our relationships with builders so we can understand what they're putting out into the field, so we can apply tooling to what we see our customers are using, and we kind of reinforce that. And we're manufacturing everything in-house in our plant, and we kind of spread out our purchase decisions on equipment based around what our customers using, not necessarily just what about we're getting a good deal on. That way we can bring it in-house and use that tooling, that equipment to test on our tooling and get better ourselves. But on the flip side, we also have relationships with these builders with they're developing innovations, right? They're designing a machine that nobody's doing, you can't get right now, right? They need to work with a partner to make sure that those solutions, make their machine look good. So, it's also part of the curve of innovation, I guess I should say. So.
Awesome. Thank you, Dave. So we have a few minutes left in the round table. So I think now is a good time to kind of say whatever you think about the current state of cutting tools, the future of cutting tools, whatever the final remarks are that you would want to leave with the audience and also with the other panelists. But we'll start with Nishant Sani over at Third Wave Systems. So take it away, Nishant.
Thank you, Jake. So I'd say maybe taking a sort of a 30,000-foot view in this, and it's ultimately at the end of the day, people, processes, and technology, and the tools that you have. I think we all know that there's pressure to do more with less. From people's standpoint, the knowledge for the workforce needs to be continuously replenished and added now that we're losing a generation and the new ones are coming in. So our role, as I see, is to bring that science behind the machining aspect. So that's our role, and ultimately get our customers getting to the first time right, or closer to the first time right? Evaluating the right cutting tools, the right tool paths, what's the impact on the part quality. Do that as much upfront as possible, and make sure that you get things up and running fast.
Awesome. Thank you, Nishant. So we'll go to Bill Sebring at Kyocera SGS with final remarks. What you think about the current state of cutting tools, the future, or any kind of, lasting impression that you want to take or give to the panelists, the audience, everyone here today?
Yeah, I mean, cutting tools will continue to evolve as they always have. Substrates will get better, PVD coatings will get better, machine tools will get better, tool holders will get better with lower run out and become more rigid. So everything will continue to evolve and get better. However, as we mentioned earlier, it's a process. This thing is a system, and they're all connected in one way. And so as the cutting tool becomes better, we have to be mindful just of everything else in the process. I think it was John mentioned earlier about cutting fluids, proper placement of cutting fluids. Also, it's not only velocity, it's also how much volume you have. Is it where it's supposed to be? Is the workpiece holding adequate? Is a tool path appropriate for the tool that's been selected? So it's just a system, and I would encourage our customers to look at it that way and continue to help develop their processes in-house.
Awesome. Thank you, Bill. So we'll go to Andrew Benson at ISCAR. Any final remarks, kind of the lasting impression you want people to take away from the roundtable today?
Yeah, something that wasn't mentioned, I think that's probably worth mentioning, is we're seeing more and more customer demand for sustainable solutions. So sustainability is a topic now, and if you consider the evolution of the workpieces are becoming more and more near net shape. They're super near net shape with additive manufacturing, and so the tools that were applied in the past are not really the same tools that should probably be applied on this newer generation of parts. And so this super near net shape means that the depth of cut is very small, and it's really finishing cuts at this point. So what you're seeing from manufacturers now are the cutting tools are being downsized. There's actually less waste because there's less carbide, et cetera, that's being used to produce the tool to be able to make those particular cuts. So really, they're kind of purpose designed for that particular application environment. And we're actually able to even use additive manufacturing to make those particular tools so small and so precise. The other sustainable type solution is the replaceable head technology. The cutting head itself is made from carbide, where the body is made from steel. And so there's a whole generation of products. Now, those have been around for a while, but now we're able to get down to even very small diameters. In the case of drilling, we're able to get down to 4 millimeter diameter with a replaceable head technology. Again, it's from cradle to grave for the product. It's a lot less of waste. So, that's what we're seeing, and we're happy to see that. I would say, just as a plug for IMTS, it's a great place to see all these innovations. We'll all be there, and we hope to see the audience there.
Awesome. Thank you, Andrew. So we'll go to Dave Beam at Greenleaf for any final remarks, any lasting impressions you want to leave, or have a kind of the current state of cutting tools or what you see coming in the future.
I'd say, I've been in this industry for almost 30 years. I think at this point, it's the most optimistic I've ever seen it. There's more capacity and more hungry. Customers are more hungrier than ever to be as profitable and be as productive as they can be. Almost as a point where capacity is almost at where we need more capacity than we've ever needed. So I guess right now, I would say to keep your eyes open and come, for example, like if you're going to IMTS, open your eyes and take on some new things that you wouldn't necessarily do in the past, and try some stuff that's possibly different. It might be uncomfortable at first, but there's some solutions out there that they're probably not aware of, that they can, fix their problems they don't even know they have. So.
Awesome. Thank you, Dave. So closing things up today, we go to John Wenninger over at Allied Machine. So the same kind of question, what kind of lasting remarks, lasting impression, what do you want people to take away from the roundtable today as far as the cutting tool industry?
Yeah. So like the cutting tool industry is evolving, the machines are evolving. So we're able to do more with the machines that we use to make our cutting tools. A big focus for us has been and will continue to be, PCD, diamond, machining, composites, aluminums, high silicon aluminums. So that's just one instance. But these aerospace alloys, the new challenging materials presents a whole new challenge to us to develop, the best solution for those industries. But and I think I harped on this a lot, but I think a lot of it comes back to the customer. We have to listen to our end users. We have to listen to the people who are using our tools, applying our tools, and design solutions around their needs. Listening to them, asking, what they need, and again, I've said it before, but what problem are we trying to solve? Really getting down to the brass tacks to better understand their needs, better understand the problem they're trying to solve, so we can have a more targeted approach in here within Allied to cultivate the best solution for the marketplace.
Awesome. Thank you, John. So a special thanks to our sponsors, ISCAR USA, Greenleaf Corporation, Allied Machine and Engineering, Third Wave Systems, and Kyocera SGS Precision Tools. And a massive thank you once again to Andrew Benson, Dave Beam, John Wenninger, Nishant Sani, and Bill Sebring for your time today, gentlemen. I appreciate the discussion, and I'll see you guys all in Chicago.
Thank you.
Take care,
Thanks,
everybody.
Jake.
Bye.
Bye-bye.
Bye.
You can listen to all of our episodes of Manufacturing Matters and Lunch and Learn podcast from the MFG Radio Network on Spotify, Apple Music, and on our websites, todaysmedicaldevelopments.com, aerospacemanufacturinganddesign.com, defenseandmunitions.com, and evdesignandmanufacturing.com.